Welcome to Chemtech Laboratory Tutorial. Today we'll be looking at change in concentration with time. In our previous video, we talked about how we can express rate of chemical reaction. Now we already know that in expressing rate of chemical reaction, we have rate of appearance of products and disappearance of reactant. Now we want to discuss the change in concentration with time and how it relates to rate constant. And this change in concentration with time works with rate laws, and the laws include first order rate of reaction, second order, zero order, down to fourth order to fifth order rate of reaction. But for the sake of the video, we'll be looking at for first order, second order, and zero order rate of chemical reaction. First order. The first order rate of chemical reaction, first order rate of chemical reaction is the change in concentration. It depends on what? The change in concentration of a single reactant. So once we say it's first order, it means we are talking about the rate is depending on what? The concentration of a single reactant. So let's assume A gives us what? B. This will be the reactant and this is the product. But the rate of first order depends on what? Just the reactant alone and not the product. Meaning that we can now say the rate will be equal to change in the concentration of A all over change in time. Remember, A is the reactant and we know that rate of disappearance, reactant is rate of disappearance, so it will be minus, will be equal to what? Will be directly proportional to what? The single reactant, which is A. And in removing the proportionality, it becomes change in A over change in T equals to K change in A raised to power 1. Why is it raised to power 1? It is raised to power of 1 because the coefficient of the reactant is 1, and we said that the rate of the first order depends on only a single what? Reactant concentration. So this gives us the, but how do we now represent it so that we can get a graphical representation of this first order chemical reaction? The first thing you do is to collect like terms. You collect like terms. That means where the A, then the other value go by cross multiplying. That means minus change in the concentration of A all over change in A equals to K change in T. T is the time taken because we are talking about change in concentration with time. Thereafter, now we have done the collecting of like terms, we will now do what? Integrate. Why do we need to integrate? To remove the differential. We integrate the variables, and when we integrate, we integrate both sides. You cannot integrate a constant, so the K cannot be inside of the integration. Instead, it will be outside. So what? At time T and at time 0. Time T and at time 0. So it means that concentration, when we remove change, it becomes, we will now introduce our natural logarithm. It becomes change in concentration of A at time T minus. Why do we put minus? Because in integration, division means what? Subtraction, and multiplication means what? Addition. So it becomes the concentration of what? At time 0 equal to what? KT. And remember that it is minus, so your minus will come this way for clearer explanation. Then we have gotten this. You will now need to arrange it according to the straight line graph. Remember that our straight line graph is y equals to ms plus c. And the variables as regard change in concentration are concentration at time t and what? the time. So that means we need to rearrange this equation to a straight line graph. It becomes means change in A at time t equal to minus kt. When minus go to the other side, it becomes plus. Say plus ni concentration A at time 0. So in aligning it with the straight line graph, it means the y-axis becomes the natural logarithm of concentration of A at time t equal to minus k. Our minus k becomes the slope, and our t is the s-axis, plus the intercept, which is natural logarithm concentration of A at time 0. So this will give us a negative slope. A negative slope. Why is it a negative slope? Because our k, which is the rate constant, is having a minus sign. So how will the graph look like? It becomes something like this. So that is what? A negative slope. It becomes a negative slope. So this is the first order. The first order helps to determine the concentration of the reactant at a particular time. It also helps to determine the concentration of the reactant at the initial stage. The straight line, the first order also helps to determine the time taken for a certain reaction to undergo what? Chemical reactions. So that is what we use the first order to do. That takes us to the second order rate of chemical reaction. We just finished first order, and we said the rate of the chemical reaction of a first order depends on the concentration of a single reactant. Now we are doing second order. That means the rate of the chemical reaction also depends on what? The concentration of a double reactant. First order, single. Second order, double. So that means we can present it as rate is equals to minus change in the concentration of A all over change in time equal to what? K change in concentration of A raised to power what? 2. You see, that means the reaction will be 2A gives us what? B. Remember that we said it only depends on the concentration of the reactant. Change in the concentration of the reactant. So because this A has a coefficient of 2, that means our raised to power will be what? 2. So you collect, the next step is to collect like terms. And how do you collect like terms? By what? Cross multiplying. That means our change in the concentration of A all over concentration of A raised to power 2 is equals to K change in time. Thereafter, what do? You integrate. Now, how do you integrate? You integrate by integrating what? Both sides. Whatever you do at the left will also happen at the right. So we have it at integrate both sides at what? Time t and what? Time 0. So it becomes time t times 0. Change in the concentration of A all over A square, which is equals to what? K change in time. You see, from here, because our rate of reaction depends on change in the concentration of the reactant, it means one of the A goes with one of the A. That means when you integrate, we have, remember the simple integration. Whatever you integrate, you say s plus 1 all over s plus 1. If you have to integrate, that is the simple principle of what? Integration. Thereafter, you apply that wisdom to this, and it becomes 1 concentration what? A at time t remember that is integration, so here is minus 1 all over change in the concentration of A at time what? 0. You close the bracket, which is equals to what? Minus KT. Where is this minus coming from? Remember that the minus is here, disappearance of the reactant. You don't throw it away, you add it to the other side of the reaction. So you will have this. So in opening the bracket, it becomes minus 1 all over change in the concentration of AT plus 1 all over change in the concentration of A at time 0 equals to minus KT. Now, the next step is to reduce this, reduce to what? A straight line graph. Reduce to straight line graph. And we know that the equation for a straight line graph is y equals to ms plus c. So sorry, I'm going to wipe the board. Okay, so by the time we clean the board, we apply the y equals to ms plus c, and thereafter it means we will need to arrange our equation. Minus 1 concentration at time t plus 1 all over concentration of A at time 0 equals to minus KT. So now you use minus to multiply all through so that we can have a positive y axis. So how do you do that? You say 1 minus times this becomes 1 all over concentration of A at time t minus 1 all over, because minus times plus will give us minus, concentration of A at time 0 equals to what? Minus times minus will give us what? Plus. So equals to KT. Before we can now rearrange it properly, because we said reduce to rearrange to a straight line graph. So it becomes 1 at concentration of A at time t equal to KT plus 1 all over concentration of A at time what? 0. So this will be the equation of a straight line graph for a second order chemical reaction, where your y-axis becomes 1 all over concentration of A at time t. Your slope becomes a positive slope, and your intercept becomes 1 all over concentration of A at time what? 0. So with this, we can be able to calculate our second order rate of chemical reaction. And how does the graph look like? Because it's a positive graph, remember our y-axis is the vertical line and our s-axis is the t. So a positive graph will give us something like this, and we'll have a positive slope. We'll have a positive slope. So this is second order rate of chemical reaction. Now we are going to prove that of the zero order rate of chemical reaction. Okay, so we have talked about first order, second order of chemical reaction, and now we'll be talking about zero order rate of chemical reaction. When they say zero order, it means that the change in concentration of the reactant is what? 0. That means the rate of chemical reaction does not depend on what? The concentration of the reactant. That means it's independent of what? The concentration of the reactant. So from there, we can now relate it mathematically that our change in the concentration of A, which is the rate of disappearance, is what? Independent of what? The concentration. We know anything raised to power 0 is 1. So that means the final case will now be change in the concentration of A all over change in time equals to what? K. So what that means that the zero order rate of chemical reaction does not depend on the concentration of the reactant, but it depends on what? The rate constant. So just as we did in the first and second, so we also apply the same in the zero order for us to get the straight line graph of the representation of the zero order rate of chemical reaction. So you collect like terms, by what? Cross multiplying, and we have change in the concentration of A equals to minus K delta T. Some of you may ask, why is there minus? Remember, there is minus is disappearance of reactant, so minus will be there. So when you have done this, you will now what? Integrate at time t and at time what? 0. You cannot integrate a constant, so your integration sign will not be, it will be in between. So at time t and at time what? 0. So integrating this, very easy. We know that it becomes A concentration of A at time t minus concentration of A at time 0 equals to minus KT. So you see, this is very simple, and in relating this to reducing it to ms plus c, which is our straight line graph, it means our y-axis becomes A at concentration of T equals to your KT comes to this other side, it becomes minus KT, while your intercept go to the other side and become plus what? Concentration of A at time what? 0. So this becomes our y-axis. Remember the x-axis, which is the variable, because we know that the topic is what? Change in concentration with time. So x-axis becomes the time, and the slope here is also what? A negative slope, and the intercept is concentration of A at time 0. That means the general formula for the zero rate of order of reaction becomes concentration of A at time t equals to K minus KT plus concentration of A at time 0. So the graph is a negative graph, so it's also slope in this format. It can be straight line, it can be curve, provided you have 2 points that what? Meet. And remember that the y-axis is concentration of A at time t, and the x-axis is what? Your time. It is your time. So what is the difference from all this derivation? We should be able to know the difference between first order, second order, and what? Zero order. So using the graphical representation, we will know that the first order, the y-axis is natural logarithm of change in concentration of A, and for the second order, the y-axis in the graphical representation is 1 over concentration of A at time t. But for zero order, it is not natural logarithm, neither is it an inverse, but just a straight concentration of A at time t. But the similarities of them is that the time is all in the x-axis. Intercept also is different in the 3 of them. So those are the differences between first order, second order, and zero order. So questions can easily be asked. What are the differences? You can state that as the differences. First order is that the rate of chemical reaction depends only on the concentration of a single reactant. Second order depends on the concentration of a double reactant, while zero order do not depend on the concentration of the reactant. Thank you and God bless you. Please keep on watching Chemtech Laboratory tutorial. Don't forget to like, share, subscribe, and on your notification button to get new videos on our site. Bye.